This is a science live session. My name is Amy Defoe. I'm one of the science teachers here at Graduation Alliance, and thanks for joining today. I hope this session is going to be helpful and informative to you. Today I'm going to continue on with, last week I talked about genetics, and I'm going to continue on with that and go into natural selection. So today we're looking at biology. I'll show you the agenda here in just a moment, but we'll also have an opportunity to have question and answers. So if you have questions about a particular topic that you're working on right now, or an assignment or an activity, there will be time set up in this session for you to get that answered. So before we get started, a couple of housekeeping items for you guys. The sessions are being recorded. It's being recorded right now. And lots of good reasons why this is being recorded. Biggest one, of course, is we know, everybody's busy, lives are busy, and we all have so many different roles and responsibilities and things that we're doing, and sometimes the time frames of these live sessions don't always work out for you. So we record them so that you can view them at a time that is appropriate and more convenient for you. We might go over something in the session that you want to go back and review, and so then you can have access to do so. And also, maybe you're not at natural selection quite yet, and maybe in a couple weeks from now, you'll be like, oh yeah, remember we did a live session about that, and you can go back and view the session when it becomes more pertinent to where you're at in your studies. The links are sent out for these live sessions, and what's great is we've got this library that's growing and growing and growing across all the different courses here at GA, which is great because, as you take different courses and you move through your courses, get to different activities and concepts, and you're thinking, hey, I'd like a little bit more information, or I wonder if there was a live session that was done on that particular activity, you can go to the library and you can click right on there and get some more information. So pretty cool. Okay, how do you communicate in these live sessions? Lots of different ways, and communication is great. It's wonderful that we can, earn our credits and get through our school at times that are convenient for us online, but it's also nice to have this kind of interaction between, teacher, student, and also our colleagues and our classmates. So I do encourage and I appreciate feedback, so please feel free to talk out loud, type in, share your thoughts, answer questions, ask questions. All of that is part of these live sessions. It helps them be better. So you can mute yourself and unmute yourself on your little box up there. So if you got some background noise going on, please do mute yourself. And then if you want to talk, you can just unmute that. Same thing with your video. You can turn your video on, you can turn your video off. That's up to you and your comfort level. And then one more thing, down at the bottom, you have a chat box. Sometimes it's easier to chat in questions instead of, talking out loud. You can also type in your responses and your answers to questions in that chat box as well. So please feel free to use whatever mode of communication works for you. I'll be checking the chat box as we go through this, but let's go ahead and get started here. So, as again, I said the agenda. So first I'm going to start off and I'm going to go over a little bit more about natural selection, show you some images, talk about it a little bit more. And then I'll have my first kind of section of questions where if you have questions about a topic or assignment, and it doesn't have to be about biology, it could be about earth science or another course that you're taking, you can do so then. And then I'll come back and I'll kind of work on a skill. Today we're going to look at predictions. We're going to look at why we make predictions, what predictions are, and then we're going to look at activity 521, which is looking at some predictions using natural selection. And then, of course, we'll end the session with a last bit of question and answer so that you can make sure that you are set for science for the rest of the week. Okay, here we go. So take a look at this image here. I always like to start off with an image and kind of a thought to get our minds thinking about what our topic is today, get some background knowledge going here. Have you ever heard of natural selection or survival of the fittest? Your thoughts on what that means? Survival of the fittest. Take a look at that picture. Anybody want to share their thoughts here? And you can talk out loud, you can do it in the chat. Stronger survive. Yeah, somebody put in there another little phrase that kind of goes along with strongest will survive. Survival of the fittest. The best live. Competition. We've got it. Yeah, you guys got the thinking going here. So when we talk about survival of the fittest, we kind of take that term and we change it, saying, the fittest organisms are going to be the ones that survive. And when we talk about fit, yeah, we're talking about, our muscles or doing a fitness test in, a PE class. Not so much. Of course, those are going to be handy. But when we're talking about fittest, we're talking about which organism is kind of best suited to live in that environment, to survive in that particular environment. So, in this case, it could be speed, as we're looking at these three organisms, two species here. And, it's who's the fastest here. So survival of the fittest is going to be, are you the fastest one, or can you maneuver so that the cheetah, I'm thinking it's a cheetah, a jaguar, hard to see from here. Would you be able to get away? Okay, good. That's kind of what we're going to be looking at here at natural selection. When we define natural selection, it's said that it's the mechanism behind evolution. It's how species change over time. Okay, so it's the mechanism behind evolution, which is how species change over time. Okay, so when you see that word mechanism, another way I like to think about it, instead of saying mechanism is kind of a big abstract word, is I like to say the driving force. It's what's causing evolution to take place. It's what's causing species to change over time. Okay, so what makes an organism want to or have to change over time in order to survive in its surroundings or its environment? Okay, and so that's the whole idea about natural selection, is the organisms that are best fit for that environment are going to survive and continue to pass on their genes. So you're going to see where genetics comes into play with this. Okay, so we look at this image here. What kind of organism is that? It looks like a giraffe, huh? Different kinds of giraffes. This one kind of looks more like a horse, huh? This is actually the stages of evolution of the present day giraffe. And now when we say stages of evolution, we're looking at how the organism has changed over time. And again, this isn't just one generation or two generations. So we're not talking decades or 100 years. We're talking a long term, could be millions of years. Well, probably not that long, but tens of thousands of years for sure. Okay, so as you can look and see, what do you think is happening in this image? What happened to the giraffe over time? How did it change? So as we go from, this is past giraffe to present day giraffe. What observations can you make about that organism? Look at its height, it got taller. The neck of it stretched out, definitely. And so in science, we have to ask ourselves, well, why? Why would an organism want to change? Or why would the neck of a giraffe get longer over time? And if you look at that image, you get a little clue. Think about what a giraffe eats. I'm seeing vegetation here, okay? So as we think about competition for this food and think about where the environment that a giraffe lives in, probably lots of competition for food. And so the ones that are best suited to that environment to get the food is going to survive. And so in this case, the giraffes that have that longer neck that can reach higher up into that tree are going to be the giraffes that are able to get the food. We all know that if you don't eat, you die. So if you're able to continue to eat, you can continue to live. Over time, these taller giraffes, again, they have genes, carry alleles for tallness or that long stretched out neck. They're going to survive and reproduce and pass on those same genes. Pretty cool to me. I hope this is interesting to you guys too. Pretty cool topic. So where did this all come from? So you might have heard of Charles Darwin, and he made a lot of observations, and he took this huge, long journey. You probably have heard something about it, and he later published a book on the origin of species. And through his travels, he traveled, all through the Atlantic, the Indian Ocean, and then up through the Pacific, and he's made the stop at the Galapagos Islands. And he summarized all of his findings and observations in that book. And what he saw is his work came from natural selection. So that means that the organism, with what he observed, was that the organism that had the best traits suited to their environment are more likely to survive and reproduce. His observations and thoughts can be kind of summed up as this, and there's a little blurb down there, you can see it. There is variation in nature. Many more offspring are generated than can survive. Therefore, there is a struggle for life in which favorable variations are preserved and unfavorable variations are removed. Lots of stuff in that statement. So when we're talking about a variation, we're talking about some type of a gene or a trait that makes us a little bit different. In the case of the giraffe, it's the length of that neck. It could be a coloring for camouflage. Those are the type of variations that we're talking about. And like it says, more offspring are created. So there's more organisms that are produced than an environment can support. So as you think about that, you get that competition of food. And so there's this struggle for life. The ones that have the most favorable variations will survive and pass on those traits. Okay, so in natural selection, there's 4 major principles that go along with it, and then I have a little +5. They are differences, variations occur among the individuals of a species. So if we look at a whole entire individual species, like ourselves, Homo sapiens, we're a species, we can look at the variations in ourselves. We can look at, the difference in our body shape, how tall we are, the coloring of our skin, our hair, our eyes. Those are all variations. Variations are passed on to the offspring, like we saw in genetics. And going to number 3, some variations are helpful. Individuals with helpful variations survive and reproduce better than those without the variations. Over time, the offspring of individuals with helpful variations make up more of a population and eventually become a separate species. So we're continuing to get that change. Again, a population is all of the members of a species, one type of species, living in a particular area at a particular time. So a population of Homo sapiens or humans, would be the population of the city, wherever it is that you live at. And then, of course, the 5th principle, all species produce more offspring than will survive. This allows, so you're thinking, well, why would an organism want to produce more than can survive? And that allows for the best suited offspring to have a better chance of survival. So it's like you're picking the best of the litter, so to speak. Okay, so let's take a look at this little imaginary pictures, and this is actually, of course, seen here in real life. Imagine that there are brown beetles and green beetles where you live. The beetles have had babies all year long, but many are eaten by birds. So again, we talk about more offspring are produced than can survive. The pictures show a progression of what occurs over time. Which do you think the birds preferred, the green beetles or the brown beetles? So again, when we first look at this, we're looking at beetles. And the first thing that we look at is, well, what's different about them? And again, that's that variation. In this case, the variation is color. We've got green and we've got brown. What do you notice happens? There's more brown. Yep. So there's more brown beetles over time. So which ones do you think the birds prefer? The birds prefer the green ones. Maybe they taste better, maybe they're slower, or maybe they're just easier to be seen. There's some type of difference between that variation in coloring that makes the bird prefer one than the other. Okay, so as we think about, well, which one is selected for? Which one is selected to survive? The brown ones, because we can see at the end, we've got more brown than green. So over time, there's less green, so the brown's going to continue to reproduce and reproduce and reproduce, and we're going to get a population full of brown beetles and not many, or maybe not even any, green beetles. So for natural selection to occur, there's 2 different requirements. First one is that there has to be variation in that population. Okay, we looked at the variation with the giraffe's neck. We looked at the variation with the beetles of the coloring. And there must be a selection that takes place by the environment. So one of the organisms, one of the variations that the organisms is going to have is going to be what we say is going to be selected for. So something in that environment is going to take place. Maybe like we saw with the beetles, it was the birds liking that particular brown beetle. Okay, so in that particular environment, the birds were making a selection. They were selecting the green beetles, making it so that the brown beetles could survive. In the case of the giraffe, variation in the length of that neck and how high they could reach up into the trees. The selection that takes place in that environment is, well, there's not a lot of food. And so the giraffes that can reach the top of the trees are going to be selected for and get the food and reproduce and pass on those traits. Okay, so as we think again a little bit more here on the beetles, it's the differences within a species that allow for survival for the ones that are selected. So we looked at the green and brown beetles, and this population colors the variation again. What's the difference between them? The predator in this environment, or the change in the environment, is the predator, and that's the bird. The bird's going to eat them. And the bird we saw prefer to eat the green beetles. Okay, so the selection is that the bird is going to eat the green beetles instead of the brown ones, so the brown beetles are selected for in that environment to survive. Okay, this shows a little bit more about the progression of the natural selection. Sorry, it's a little bit blurry, but I really like this image here. So we've got, looks like a little population of elk or deer. And as we look at, we have this overpopulation. So we talked about it. 2 requirements here is that you have to have, as we think about variation. So we know that we've got darker colored ones, lighter colored ones, okay? And more are produced than can survive. Something happens in the environment, there's going to be selection. One of the variations is going to be selected for. Over time, they're going to reproduce and pass those on. So it looks like in this particular scenario, it's looking like the lighter colored ones are the ones that ended up dying off. And over time, the darker colored ones were able to reproduce and pass on those traits. Can you think of ways, so we talked about evolution, natural selection is the mechanism behind evolution, how an organism changes over time. Can you think of ways that an organism could be selected for or best suited to its environment that could cause this type of a change? I gave a couple examples in there. So camouflage is a great one. As we take a look at this owl, you know, think of colorings of an organism and how can they blend into their surroundings to not be, you know, a predator. Hey, welcome. We're just going through, we're talking about some natural selection. We're going to get to a break here in a moment. If you have questions. So we're looking at natural selection and thinking about ways an organism can be selected for. Okay, so camouflage, that is a great one. So how can an organism blend into their surroundings? So of course, a predator can't find them like we saw with the beetles. Height, like we saw with the giraffe. Another one is like in grouping. So as you think about zebras, have you ever wondered, you know, why they have that striping on them? And as you think about a population of zebras, as you usually see zebras kind of close together, they move around in groups and packs, and that's because it's a type of variation and a kind of a defense mechanism, because a predator can't figure out with these stripes, you know, where does one end and one begin as they're going to prey upon them. Anybody think of any other ones? Maybe going back to that first one, thinking about speed with that cheetah. Okay, so that's what I have so far there on the first part on natural selection. Does anybody have any questions about what we just discussed, or does anybody have any questions about an activity that they're working on right now? I'm going to give you a little bit of a moment to think about that, and again, you can use the chat. function if you want to type in, or you're welcome to unmute yourself. Okay, keep that handy because we'll have another question and answer period here at the end, but let's go ahead and move on then. So talking about a skill, it's going to go along with natural selection. We're going to look at prediction, and it's kind of funny because we think about predictions, even though we don't think about predictions, but we're making predictions all day throughout our daily lives, and we probably don't even notice it. So a prediction is a guess about what might happen in the future based on observations that you've made. Predicting is closely related to other process skills such as observing, inferring, and classifying. Many of these process skills are in fact dependent on other process skills. So as we think about the scientific method in completing scientific investigations, which is kind of the form that we use to answer questions in science and in daily lives, we make predictions. We, start off before we test this, we make predictions about what we think might happen, kind of activating that prior knowledge that we already have. Some examples of predictions, it's cloudy out. You wake up in the morning, it's cloudy, so I predict that, maybe it's going to rain today. Maybe bring that umbrella or that rain jacket with you. You can think about if you walk into a room and you see a light switch or a switch, and you say, oh, hey, if I flip this, the light's probably going to turn on, right? So those are predictions that we make based off of observations that we've already had prior. Dependable predictions. So we discover patterns and observations that help us make a dependable prediction. Reliability and dependability in predictions allows people to plan for future events. So again, as we talk about, the weather, we can make observations and collect data off of what has happened in the past, in particular weather patterns, or, thinking about different months of the year, when you might get more rain, when it's going to be hot, so that we can then plan, for future events. Same thing goes as we study, earth science, and we look at things like volcanoes and earthquakes, that tectonic activity. We can, kind of look at observations or take evidence from the past and make predictions to help us plan for the future. When we make a prediction, we want to use our senses to observe and collect data and information. Notice any patterns through classification, make connections to what we already know, and then predict what you think is going to happen in the future based on these things. Helps us kind of prepare, be ahead of like the next step to happen. So how do we use this in our daily life or in science? Like we talked about it in weather, storms. When is it okay? I should probably stay home. I shouldn't go outside. How much food do you need? You make predictions about planning out your breakfast, your lunch, and your dinner, and maybe you got to bring it with you if you're heading off to work. Again, we talked about earthquakes. We make predictions for tests in school based off of, maybe the objectives that we get in the unit or the course outline. You can make predictions about tests in school from, maybe having conversations with people or having conversations with your teacher about the test. Okay, so when we use background knowledge, I always usually, if you've been to my live sessions, I always talk about this, activating that background knowledge. And it's amazing because we are going through our lives and we are just using our brains as kind of a filing cabinet, and we're getting bombarded with information and observations all day long. And if we're filing it away, we pretty much don't even, realize it. And so when we access that background knowledge, it's like we're trying to open up those filing cabinets and use what we already know or what we've already observed to do so. So in science, we use the past as the key to the future. So meaning that is we look to Earth's history to predict what will happen in the future and prepare for that. So like storms, earthquakes, volcanoes, and the different seasons. sometimes in our lifetimes are too short to actually see some of these things occur. And so we have to look for other evidence to show what's happening on Earth and what we can predict to happen. Okay, so let's take a look at this natural selection scenario. And this comes from this is 521 in biology semester 2, unit 5 on natural selection. And we're looking at the scenario on moss. Pretty interesting. You're like, moss, huh? Yes, and this is actually a true scenario. This is called the peppered moth, actually. And you can probably look at the pictures and make your observations why it's called the peppered moth. So we think about natural selection. The first thing we have to look for is, well, what's the variation? These are the same species. So this is a population, and of course there's more in that population, but they're just showing us 2 examples here. What's the variation in this population of moths? Both peppered moths. The color. So we've got dark moths and we've got lighter colored moths. Okay, and you can also look at that background. These moths live on trees. This actual scenario took place during the Industrial Revolution. We're looking at an area outside of London in England, and this is looking at the tree bark. So something in the environment changed that caused the variations in these species and one to be chosen for. Okay. Okay, so let me go to this little scenario. So I'll go back to that picture. The peppered moth is found in England during the Industrial Revolution. We think about, well, what was the energy source? This is when Industrial Revolution, this is when we had big beginnings of factories. And coal was used as the top fuel during this time. It burns hot, good energy source. But the problem with coal is it's very dirty. And it produces a soot. The soot that would come out of the smokestacks from the factories. We're producing these particles into the air. Eventually, gravity pulls them down and it settles. Well, it settled on, what happened is the soot began to cover the trees, which changed the coloring of the bark. So eventually, the trees became darker. Okay, so again, this is kind of the natural, what the original coloring of the bark of the trees was. And then as the Industrial Revolution took place and that coal was emitted out, it landed on these trees and started collecting and covered the bark to make it this color. Okay, so as we think about, these moths, thinking about, survival of the fittest. In this scenario, which moth do you think would have survived? And of course, we have to have something in the environment that's going to change. Well, as we think about it, everything is connected in an environment. So there's got to be a predator. There's got to be something that eats these moths. And of course, any ideas? And birds. Okay, yeah. So we have to think about, in this case, which one can you see better? Think about camouflage. So in the lighter colored one, yeah, this dark one stands out. When coal came in, pollution took place. Now that black one blends in and now it's the white one that stands out. So as we think about the term, looking at it from the point of view of prey and predator, if you're a predator, you're gonna pick the one that's easy to see. You're gonna eat that one for sure. Okay. So in 521, we get a couple different questions. There are 2 types of beetles, those that are brown and those that are green, like we saw in the picture. The beetles had babies all year long, but many are eaten by the birds. The pictures kind of show the progression of what happened. So again, going back, we see there's brown and green. The bird's going to eat them. Over time, this is what the population of those beetles looks like. First question here is, what is the variation? You got it, that's right. Color, the color of the beetle is the variation, green or brown. So coloring is our variation. And we know that there's something about that variation that that predator is going to choose one or the other. Which beetle is selected for according to the natural selection theory? What will happen to each color of beetle? So when we think about selected for, that means which beetle is best suited to its environment and survive. So it'd be survival of the fittest. So that's the selection. What is selected for? Which organism or which variation is selected to survive? Somebody got that? Yep, the brown beetle is the one that is selected for. We would call the brown beetle the survival of the fittest because for some reason, maybe camouflage, it is able to continue to live, reproduce, and pass on. So over time, the population becomes more of those. What do you think will happen to the other color of beetle? Definitely, as you can see, it's going to get preyed upon. So let's go back to that beetle. Oh, we just did number 2. Okay, so we're going back to that scenario between the beetles. So this is pre-industrial revolution. Okay, we got the peppered moths, and this is after the Industrial Revolution where we have that change in the environment. Something happens, coal is produced, it pollutes the trees. Here we go. Gives you a little bit of information, percentage of each type of color in the population, light to dark. So we're saying in 1848, 92% were light, 2% were dark. In 1895, it flip-flopped, 5% dark, 95%, or sorry, 5% were light and 95% were dark, which totally goes along with these images and what happened. So in the peppered moth scenarios, what is the variation? So first, look at the 2 examples of that species of the peppered moth. What's different about them? That's the variation. You're right. So the variation is color. Light, dark. Okay, the variation in this scenario is the coloring of those moths. They're different. Lighter, darker. Okay, and what is the selection? So thinking about natural selection, which of these moths is selected for? And it's different in each scenario. So as we think about it, post-revolution, industrial revolution, as we think about the 2 moths, which one is going to be selected to survive? Survival of the fittest. So again, when we talk about the selection, this is going to be the variation that is chosen for, that's best suited to that environment, going to survive and pass on those traits. So in the darker scenario, the dark moth is what is selected for because it can camouflage and blend in. We looked at this one. The lighter moth is the selection because it, again, blends in the scenarios. So the selection depends on if we're looking, pre-industrial revolution or post-industrial revolution or during the industrial revolution. Okay, now we get to a little prediction. What do you think would happen to the population of peppered moths once coal was decreased and the trees no longer were covered in soot? Okay, as you think about now, we're looking at, how we can preserve our earth and make it less polluted and less, kind of lessen our impact on the environment. And so we can look at coal and we can say, yeah, it's pretty dirty, pretty big source of pollution. It's harming the environment. Could we use other sources? And maybe they stop using coal or reduce the amount of coal that's being used and find another energy source. Maybe using gasoline. You can think of finding natural resources like water and solar energy. And so as coal is reduced, what do you think is going to happen to those trees now? So this is what it looks like pre-industrial revolution without coal. This is what the trees look like during industrial revolution with that coal. Now, what would be your prediction for the next phase once we limit out that coal and we've actually can see what has happened as it's been some time since the industrial revolution? What do you think is going to happen to that bark? What do you think is going to happen to the moths, the population? Well, if you said the bark is going to start lightening up again, you're right. So as we stop using that coal, we stop producing soot that covers that bark, and the trees are going to go back to what they are naturally like. So then as we think about this population of beetle, the variation again being color, when there is this coal soot covering those trees, we know that The darker ones are going to be selected for and survive and pass on their traits. And so there's going to be more of the darker beetles. But we know in the beginning that the natural state, it's the opposite. The lighter colors are camouflaged. Less are going to be eaten. They're going to be able to reproduce and pass on. So as we think about the bark now becoming this natural color again, we're going to get a higher population of lighter beetles again. So again, they're going to change and be selected for survival of the fittest in that particular environment. And as we can see with natural selection and evolution, environments change as we saw in this scenario. Does anybody have any questions about 521? Or we can go ahead and open it up to questions about anything else that you might have. As you're thinking or typing out a question that you might have, I'm going to go ahead and keep talking here. So again, as you are working through your courses, you have this great resource, this library of live sessions that your teachers have created. So definitely look to that. If you're feeling like you're a little stuck on something, or maybe you're interested in a topic and you want to get a little bit more, take a look at one of the live sessions. Or if you're stuck on an assignment, go in and find that topic. It might be labeled with that actual activity, or maybe the unit that it's from, the topic. And you'll probably find that, your teachers are going to go through, like I just did with 521, kind of go through that activity. So use that as a good resource. Another one is make sure to ask questions if you're stuck or you're not understanding something. Sometimes just having somebody explain it in a different way than reading it makes all the difference in understanding. So figure out, what's your best form of communication. Your teachers use them all. So, if you chat, email, Google Voice, Google Hangout, what it might be, you please use that to your advantage and, shoot us a question. We'll respond to you as soon as we can. And, as we think about it, we're all here to support you guys and get you through your courses. Going off of that as well, as you're thinking about live sessions, or as I'm thinking about and preparing for my live sessions, I always wonder, what should my next topic be about? If you have an idea for a topic or a skill or an activity that you'd like me to go over, please let me know. You can tell me here, you can send me a chat or a text message, an email. Okay. So again, as we think about this and moving forward, thinking about natural selection, kind of summarize it all up. So as we think about a population, we know that there's always going to be that variation in that species. And we know that with that variation, one variation is going to be better chosen for that environment. And so we get that idea of survival of the fittest, is that the organism that's best suited to that particular environment at that time is going to survive and pass on those genes for that variation. Okay, and how do we, kind of look at this and kind of think of the skills as we're thinking about using prediction? Maybe think about throughout your day today, how many times have you already made predictions without even thinking about it? And again, as we look into science and answering questions that maybe we weren't around to do so, or as we think about predicting things in the future, we look at the evidence that we have, and we look at the observations that we've made with our background knowledge, and we use that to help us make these predictions to prepare for the future or prepare for what we think might happen. Okay, well, thanks for joining today in this live session. Everybody have a great week in science and in the rest of your courses, and we will see you guys again next week.